So far, we've graphed absolute value equations and described it. So far, we've described absolute value equations and then graphed them. Now we're kind of going to go in reverse and look at tables and learn how to write the equation based off of those tables. So when we have an absolute value function, the table must have two things. It must have a vertex. And we talked about what a vertex is when we look at a graph. Now we'll talk about what it looks like when we have a table. And the second thing we must have is the y values change by the same amount. Up or down. So what I mean by that is that the y values are going, down by 3 and then up by 3, or maybe up by 5 and then down by 5. So maybe we or we should say up and down. So let's look at this table here. So what I like to do is I like to kind of say, okay, what's happening here from this y value to that y value? We're going down 2, down 2, down 2, down 2. Now I'm going up 2, up 2, up 2. So because my rate of change is 2, I'm either going down by 2, subtracting 2, or then I'm adding 2. That's a clue that it's an absolute value function. So then what is the vertex? The vertex is going to be that point where we change. Right here at 0, -5, that's when we went from going down by 2, -2, to up by 2, this +2. So this is my vertex right here. So that makes my h value of my equation 0, and my k value -5, and my a value will be is going to be +2, because at the end of the table I'm going up by 2. If these signs would have been reversed and it was +2 over here on the left and then -2 down here, then my a value would have been -2. So this is an absolute value function. The equation is going to be y equals 2, absolute value of x minus 0. You don't have to put the -0 and then -5. So instead you could have y equals 2 times the absolute value of x minus 5. Either one of those is okay. We're going to get to the point where we're not going to write the -0. Okay, so then the next one, let's see, if we go from 33 down to 18, that is subtracting 15. And then 18 down to 9, we're minusing 9. Then subtracted 3 and plus 3. So you're seeing that this number is not the same. We have -15, -9, -3, plus 3. So that number is not the same, so this is not an absolute value function. Okay, here we're adding 4. -9 plus 4 is -5. We're adding 4 again to get -1. And then the y values go back down to -5, back down to -9. So now we're subtracting 4 as we go to the right side of the table. So we're adding 4 at the beginning, at the start of the table, +4, +4. and then minus 4, minus 4, minus 4, minus 4, minus 4. So this is an absolute value function, and the vertex is right here where we change. So my h value is negative 4, my k value is positive 1, and my a value is negative 4 because that's where we ended off right here. Now remember, in our absolute value function, the parent one, that the x-coordinate of the vertex is your h value, and that the y-coordinate of your vertex is your k value. So that's where I get these from. So now we can write our equation, y equals negative 4 times the absolute value of x. Instead of writing x minus negative 4, we're going to write x plus 4, and then minus 1. Oops. Minus 1. So that is our absolute value function. Now letter D, we're adding 2, adding 2, adding 2, adding 2, adding 2, adding 2. So we don't ever change from positive 2 to negative 2. Like our rate of change, if this were an absolute value function, we would eventually see a change to minus 2. But it's all plus 2 right here. So no, this is not an absolute value function. Now these examples, we're going to write the equation from the graph. And again, I'm going to write this here so we have it. So for each one of these problems, we need to identify a, h, and k. So the vertex here is at 1, negative 4. So that means my h value is 1, my k value is negative 4, and then to find my a value, I'm going to count my slope. So see, if I go up 2 and right 1, I'm on the absolute value graph still. So my a value is positive 2, which makes the equation y equals 2 x times the absolute value of x minus 1 minus 4. Now in example B, we see that this absolute value function is pointed downwards. So again, let's find our a, h, and k. So h is negative 2. Our k value is positive 3, because our vertex here is at negative 2, 3. Now our a value, we're going down 1, right 1, and we're on the graph still. So a is negative 1. So negative 1. You don't have to write the 1, just make sure you have a negative sign there. X, instead of writing x minus negative 2, it's x plus 2, and then plus 3. Finally, we're going to create some absolute value graphs based off of the information here. So when this one says this has a range of negative 5, infinity, this tells us two things. Because the range goes up to infinity, that means a is positive. Because it has a range starting at negative 5, that means the k value is negative 5. And because it's translated left 2, that means my h value is negative 2. So then we're going to take these pieces and make an equation out of them. So y equals, this doesn't tell us anything about a vertical shrink or stretch, so we're not going to put a number in front of the absolute value bars. So absolute value of x plus 2 minus 5. Remember, h and then k goes on the outside. Letter B says as x approaches negative infinity, y approaches negative infinity. As x approaches positive infinity, y approaches negative infinity as well. So this end behavior right here tells us that our function is going downwards. Our y values are approaching negative infinity. So that tells us that a is negative. Translated up 7 means k is positive 7. And a vertical shrink, that also means that a is less than 1. It doesn't tell us by how much, so we get to pick. So y equals, we need a number less than 1 in front of the absolute value, and also negative. So let's go with negative 1/2. We don't have any horizontal shifts, so we just leave absolute value of x, and then plus 7 on the outside. Right, then letter C, if we have a vertex of 2, -1, that means my h value is 2, my k value is -1. We're reflected over the x-axis. That means a is negative, and no vertical shrink or stretch. That means a is equal to 1, and we don't need to write that 1 out in front. So y equals negative absolute value of x minus 2 minus 1. So you really need to know or have the parent function or the standard form of our absolute value equation either written down everywhere or memorized so that you can see where these values go into that function. This one says has a vertex in quadrant 2. So quadrant 2, we have 1, 2, 3, 4. So our vertex is over here somewhere. And it doesn't really tell us anything else about that, so we get to pick. But this tells us that our h value is negative, k is positive, and a vertical stretch means a is bigger than 1. This isn't telling us if we have to open up or open down, so we don't know if it should go up like that or down like this, so we could do either one and still be correct. Y equals, I'm not going to have a negative a value just because I don't want to accidentally mess up. So we'll go with 3. So you can have any number right here as long as it's positive and it's bigger than 1. X, whoops. And our h value is negative, so when I write a number in here, it needs to be plus that number. So plus 4. And then k is positive, so how about plus 11? So we had a little bit more freedom on that one. So hopefully talking about the graphs of absolute value functions and how to graph those previously made this a little bit easier to grasp. So thanks for watching the video. Make sure you like and subscribe.